Now, see here an AC voltage E is equal to 200 sin 300 t is applied across a series combination of R equal to 10 ohm. You are given R is equal to 10 ohm and L is equal to 100 millihenry, that is L is equal to 800 into 10 raised to power minus 3 Henry. Calculate the power factor. So, first we have to calculate here XL and we know it omega is equal to here 300. So, we can write XL is equal to omega into L. So, that is 300 into 800 into 10 raised to power minus 3 ohm, that is coming here 240 ohm. Now, we can calculate here resistance, that is called Z impedance under root of R square plus XL square, and that is coming here 10 square plus 240, this is whole square, is equal to around 240.2 ohm. This is the value of Z, and we know power factor, that is P is equal to here, that is cos phi, that is called power factor. Cos phi is equal to here R by Z, that means 240 divided by 240.2, that will be coming 0.0416. So, this is the value of power factor. Now, see in this circuit there is one inductance and one resistance, values are given here. Similarly, here this is the LCR circuit, capacitor, resistor as well as inductor. Here we have to calculate the ratio of the power factor of circuit B to the power factor of circuit A. So, in the first case we can take for the power factor of the circuit A, we can write for circuit A here Z is equal to, we can write under root of 3 R square plus R square, that is here under root of 10 R square, that is R under root of 10. And we can write the power factor cos phi is equal to R by Z, that is R upon R under root of 10, this is cancelled, this is 1 upon under root of 10. This is the power factor in this case. Similarly, we can go for the second case here, and now in the second case we can calculate Z is equal to under root of, for the circuit B here, Z is equal to, this is R square plus 3 R minus R square, that will be equal to here R under root of 5. And now we can calculate the power factor cos phi dash is equal to here R by Z. So, R by Z is here, that is here only the R. So, that is 1 upon root 5. Now, we can calculate the ratio of these two. So, the ratio of these two can be calculated easily, and that is here by what you have to calculate here, the ratio of the power factor of circuit B to circuit A. So, that is cos phi dash upon cos phi is equal to, that is 1 upon root 5 upon 1 upon root 10, that is coming here, and it is here root 10 upon root 5. So, that is root 2 upon 1. So, this is the ratio of the power factor in these two circuits.